Good afternoon, everyone. My name is Maimai Prayongrat, and today I'm going to present about climate change mitigations and adaptations of UK complex-to-decarbonise homes, focusing on building fabrics and system upgrade approaches. So let's begin with the context behind my research. I found that climate change mitigations and adaptation is needed and the greenhouse gases emissions need to be reduced from buildings. And millions of homes in the UK need retrofitting those purposes, as well as to reduce overheating risk in the more extreme weather in the future. But currently, complex-to-decarbonise homes are often overlooked in the decarbonization efforts. So in this research, this study will focusing on two complex-to-decarbonise homes in the UK to assess the effectiveness of the different retrofit measures. So the literature review. So as you can see on the slide, this is the list of the example of complex-to-decarbonise homes. There are many of them across the UK, and this picture shows their distribution across London. And these homes often have high energy costs and poor performance, as well as technical and financial challenges in retrofitting. And before we go on, this is one of the two selected case studies. It is a Victorian mid-terrace house built before 1990, and the reason that it is defined as complex-to-decarbonise is its location, located in conservation area, which restrict the facade alterations, and also the occupants of this building is owner-occupier property, so retrofit feasibility depends on the owner's finance. And the second case studies. This is a social housing high-rise flat for retirees built in 1960s. And this study will focus on the two-bedroom flat on the top floor as it faces higher overheating risk. And the building height and also vulnerable occupants of the building make this case study complex-to-decarbonise. And this is the methodology of their study. So this is modeling based research. So the baseline model is created but reoriented to the worst case scenarios to assess overheating risk. And then these retrofit packages will be added to the baseline model to improve building fabric and system, as well as the combination of both strategies. And the models will be simulated in these weather files from current to future climate scenarios and based on UKCP09. And the output for further analysis is energy consumption and indoor temperature. But to add some more detail about overheating assessment, this study is going to based on 60TM59 with additional guidelines as shown in the table. So the results of their study. These graphs show the energy consumption of the each simulations from now until 2080 in darker color. And the x-axis show the different retrofit strategies. So from this graph, this study found that the passive heating with electric heat pump gives the best result in reducing energy consumption of both case studies. And by comparing fabric improvement and system improvement between passive heating and heat pump replacement, this study found that passive heating can reduce energy consumption more than improving system without any fabric retrofit. However, in none of the retrofit strategies reach 2030's net zero target by the as shown by the back line. And this is the overheating results. So this one is from 60TM59 criteria A and B of both case studies. And the graph show numbers of rooms that in each overheating category from green, from pass to extreme fail. And we can see that in case study 1, further passive cooling with electric heat pump show the best result in across all weather scenarios. But in case study 2, the combined passive heating and cooling measures shows better performance with option 3 for criteria A and option 1 for criteria B. However, in 2018, none of the strategies passed TM59 criteria. Then this study conducted a comparative analysis to find optimal solution, comparing energy consumption and overheating risk. This graph shows the current climate scenarios of the energy consumption in the left y-axis, and the right y-axis show number of rooms that pass TM59 both criteria. And the result emphasizes that combined passive heating and cooling with electric heat pump can give the optimal results for both case studies. So that brings me to the discussion and conclusion. There are potential unintended consequences from those retrofit strategies which should be considered, as well as it should be noted the limitations of the process that might affect the results with accuracy and precision. And the conclusion of this study is that the passive heating and cooling strategies combining with electric heat pump is required to reduce energy use and as well as effectively mitigate overheating risk. However, future research is needed to explore more additional measures to be used for complex-to-decarbonise home to address urgent climate issues. Thank you for listening.